The first misconception that we are going to talk about is completing a square, where we are supposed to factorize out a in ax squared from all the three values, ax squared, bx, and c. But at times you do not tend to do so from c. So as a result, in the third and fourth step, we can see that we multiply the a into c at the end, which does not give the correct answer. So the correct method is to factorize out a from all the three values, and then after completing a square, you multiply back the a to c over a, which results in c. So if you're unable to understand what I spoke just now, this example. So you factorize 2 in 2x squared from 2x squared and 2x, but not from 2. So in the end, what we do is that we multiply the 2 into the 2 which we did not factorize, causing a problem in the answer. And to prove this, let's substitute x by 1. So you can see that 2x squared plus 2x plus 2 equals to 6, but 2 bracket x plus 1 over 2 square plus 3.5 equals to 8, and thus they are not equal. So the correct way to do this is you factorize out 2 from all the three values, and in the end you can get the correct answer. And we substitute x equals to 1, and in both 2x squared plus 2x plus 2 and 2 bracket x plus half square plus 1.5, both of them equal to 6, and thus they equals to 6.
This is Misconceptions number 2 by Chung San Ho. The topic is general equations. This is the correct equation to solve for x. Negative b plus or minus square root of b squared minus 4ac over 2a. The misconception is some people might incorrectly write the equation such as x equals to negative b plus or minus square root b squared plus 4ac over 2a. The plus is what's wrong. The misconception comes about when positive is confused with negative. The equation is rather hard to remember at first. Wrong values of x will arise when you're trying to solve an equation. And even worse is, if b squared plus 4ac turns out to be a negative number, the square root will be undefined, as negative numbers cannot be square rooted. This is an example of what will happen if you use the wrong formula. So, let's take this equation. 2x squared plus 9x minus 18 equals to 0. 2, the coefficient of x squared will be a. 9, the coefficient of x will be b. And negative 18 will be c. Normally, if the general equation is used correctly, it will result in x equals to 3 over 2 or x equals to negative 6. If done wrongly, using this formula, negative b plus or minus square root b squared plus 4ac over 2a, the answer cannot be found because 9 squared plus 4 times 2 times negative 18, square root that is equals to square root of negative 63. It's undefined because the answer cannot be found. This is because a number is negative. Negative numbers cannot be square rooted. So this wrong formula will lead to different answers, or maybe even undefined answers.
We're going to discuss our third misconception now, and this misconception is also involving completing a square. So let's go through the example question. Express the equation 3x squared plus 12x plus 3 in completing the square form. First, we'll go through the wrong way of working this question out, and on the way we'll discuss about the misconception. And as you can see, in these two circled numbers, this is where the mistake and the misconception is, because we forget to divide bx by 2. So in fact this 4 over here, it should be 2, and this minus 16, it should be minus 4 instead. So now we go to the correct one, and from here we can see that if you do it correctly, this is x plus 2 squared minus 4 plus 1, and the final answer is 3 bracket x plus 2 squared minus 9. And if you compare this with this, it's really different.
My misconception is on inequalities and how people tend to mix up and or. So in inequalities, n means an intersection of the two inequalities, and r is the union of both of them. So in this table below, I have done a few examples of the correct and incorrect applications of n and r. So here, 2x less than or equal to 4 and negative 4 less than x, which is less than 8. So I just simplify x, which is less than or equal to 2, and I draw the number line here. So earlier stated that n is referring to the intersection of the two inequalities. So negative 4 less than x, which is less than 8. Next one is x is less than or equal to 2. The intersection is between these 2 points. Therefore, the answer is negative 4 is less than x, which is less than or equals to 2. Okay, the next example here is on r, which is as stated above is union. So I draw the number line again. The values of negative 4, 2, and 8. And I draw the 2 points of the two inequalities here and here. We find that the union, the two inequalities in r is x is less than 8, because it's this whole part. So the incorrect applications of n and r are in this column right here. And what I've done basically is just swapping them to show how the incorrect applications of the two n and r's can be made. So the same as the previous examples, except that n, from the point of a student with misconceptions, it would be union instead of intersection. And therefore, the 3 points which are negative 4, 2, and 8, and we take the union of the whole thing, which is x is less than 8. That is incorrect, because and is referring to the intersection and not the union. Similarly, for the second example, which is incorrect, or which is supposed to refer to union, is now taken as being referring to the intersection. And so we have here the same as here, and since we are supposed to take the union, we take the intersection for the incorrect example. And so we get negative 4 is less than x, which is less than or equals to 2.
The misconception I'm going to be covering is that people sometimes, when they try and factorize the equation using completing the square, they do not correctly minus the square. For example, as you can see here, in the correct version of the calculation, this square root of the coefficient is minus and then divided by the incorrect version is not. As you can see, as we work through the results, the end results are vastly different.